All right. Looks like we were a few minutes early. And let's kind of hang out for a minute before we get started. Um, got some interesting stuff to talk about today. What our approach is going to be, and where we're headed. So I think it's going to be a fun-filled afternoon. Um, I'll do some setup while we wait. Just kind of create some folders here, and we're going to copy some files in. Where am I at? Ah, that's where I want. That's why you're using relative paths. Right. So just to kind of get this out of the way, I am going to be using a set of assets for this. Um, if we look here, the chess assets are by Burnett. You can find it on this Creative Commons link here. If somebody wants the link, I can provide it. But if we do reference any specific assets, that will be where they are from. My T-shirt is somewhat blending in with the shirt, the couch behind me, so there's a little bit of clipping there. Yes. So what are we gonna do today? It's 11:32. We'll go ahead and get started. So what's the purpose here? So I want to explore coding with AI. I've done some work with AI. I can maybe describe that at a later time. But I want to see like what tools are out there and how we can accomplish some sort of iterative process to have AI build something that might be considered somewhat useful, somewhat obtainable, but then also we could use that information to uh, see how efficient things are in the ecosystem right now, right? So as a software engineer, we know that the industry is changing in that the more AI, the more LMs develop, the more that is going to be at the center of what we do. Um, and frankly, there's some thought that it may right out replace us. But at least in the midterm, the midterm before that happens, which I have some pretty high doubts that that would completely happen in the midterm, we need to take a look at it and focus on how can we use these new tools to help us, right? So some of us, like myself, we mistype things, we misspell things as we're typing. We have things like spell check, correction, etc., that kind of assist us. And so right now I'm looking at LLMs as that answer. So how do we code things with AI? How do we utilize AI? So what are we going to do today? Um, get this off the screen and let's look at Obsidian. So I'm using Obsidian to take notes. I am trying to utilize some of its features as far as uh, graphing goes to kind of map out this project. Obsidian is something new that I'm trying to look at, so I kind of want to see where we can take this. So what are we doing? We're going to ask we're going to ask AI, in this case ChatGPT, to create a test application for us. In fact, to give you an idea of what that might look like, um, I kind of put together something here um, that we could utilize or as like a starting point. And so let me open up a new tab. So what I'm going to do is show you what I already kind of put together with some of this experimentation. This I did completely on my own. And we should be able to just run it here. And there we go. So as you can see, what this is actually is a chess battler. So it takes a ChatGPT instance and plays chess against ChatGPT. It uses a Go. This is all built in Go using Fine. And then it uses, there's a library out there called by Not Nil called Chess that's on GitHub, and it uses that to determine whether or not the moves that are being made are accurate and whether or not those moves can be made. And so the idea here was to understand the level of like cognitive thinking that the LLMs are doing and whether how accurate they could or couldn't be. And if you notice in the background here, we've got some errors that are being spit out. Those are moves that are being suggested by the LLM that aren't actual moves. And so kind of my hope here is now instead of building this myself, which only took an hour or so, that we can we could then ask the LLM to build something similar to this and at least be able to get to a point where a player could play another player, or we can even start plugging in LLMs there and comparing, what does ChatGPT look like versus Claude versus Google Gemini, etc. That's kind of the purpose of this project. That's kind of a separate topic, but this kind of gives you an idea of what we're looking for. It doesn't have to look super fancy, it just has to be functional. The pieces have to be moved with mouse clicks and they have to be valid chess moves, right? And then some way to determine what the winner is. So we'll see how far we can get. I kind of want to time bound some of these to 4 or so hours. So let's take a look now. So then we understand what our end goal is. I kind of put together a plan. And so I'm looking at what we have here on the screen is just Obsidian, and I'm using it to kind of map out or mind map what we're going to do here or what the plan is. And so what we want to do is we want to start with, that's interesting. So yeah, what we want to do is we want to start with and just kind of go through each of these LMs. I'm not going to do all of them today. I'm going to start with just ChatGPT. My goal is to give a time limit of 4 hours from the time I start to the time I finish with a given LLM to see what is produced, to see if it actually produces something worthwhile, to see if it's something that's actually usable. And then also, this is kind of an experiment to say, okay, how valid is this for me to code to bring back into my day-to-day workflow for the things that I normally do and see how it can apply. So with that said, let's look at a couple of the criteria that we have here. Does it look like chess? It's number one. Does it function like chess? A couple of bullet points. I want to be able to move pieces. Does it only allow valid chess moves? Does it properly provide feedback when an invalid chess move occurs? These are just some of the ideas. We might expand upon that. How well does it code? So the code that it's returning to me, how good is it? Does it create errors? And then if it does give me an error, how well does it receive correction or feedback? If an error is produced, can it rectify the error with that feedback? So meaning that if it gives me an error and I say, hey, there's an error, does it come back and say the error yes, I'll fix that error, or thank you, or correct it. I've had some experiences in the past just because I've done some of these exercises with LMs where it has suggested or it has seen the error, said it fixed it, and still gives me back the exact same error in the file. So I'll have some fun with that. And then were we really able to create something useful? So is it just, does it visually look appealing, or does it actually function? A little bit about what I'm choosing here. I'm choosing Go, and I'm choosing desktop apps to Go, which isn't really a norm. You don't really see this a whole lot, but I feel like it's actually a really good test case for LLMs because it's kind of an obscure area of Go development. It's why Go. I think Go is fantastic, and I use it for a lot of backend development. Uh, and I use for a lot of APIs, a lot of automation workflow. I've even incorporated some of the LLM functionality into my workflow. And so we can talk more about that later, where I actually call the LLM APIs and I make decisions, et cetera, et cetera. But today we're going to focus just on how are we building or what are we building. So let's look at our interest list. So we've got ChatGPT, we've got Google Gemini, we've got Claude, we've got Copilot. As you can see, there's also a lot of other things that are listed over here on the left. Those are things that we can explore. But what I try to do is kind of build out some sort of graph that kind of interlock them to a particular, code path. For instance, I really want things in VS Code. I don't really want things in a chat interface, although that's what we're going to do today. And so I created a graph that kind of mapped everything out to VS Code. And so whether it's OpenAI directly via Copilot to get to VS Code, or Cody to OpenAI, or Anthropic to get to VS Code, we have a couple different options there. And so I'm trying to kind of explore those options and see what it looks like. But it looks like really we've got Copilot, Cody, and Tab 9 is the three primary offerings. We also have things like Devin out here, which I'm still exploring, but this kind of gives us an idea of where we're at on the so-called graph. So what do we create from here? We're actually going to create something. We're going to use ChatGPT, and we're going to just kind of start with a basic set of questions. And I'm going to kind of lead ChatGPT a little bit. Instead of just saying, hey, create this, I'm going to kind of give it some like primer questions that will sort of get the LLM primed with some data that when it starts to actually create something, it'll kind of use its own inference. I realize with some of the newer LLMs that are coming out with ChatGPT specifically, where they spend quote unquote more time to think and more time to infer, we might be able to skip some of those steps, but we're not there yet. So it's maybe like talking to a 10-year-old who has an extreme set of knowledge. You probably wouldn't want them to just go and drive the car, but if you kind of work with them on how to discover how to drive a car, you might feel comfortable with them driving the car after a little bit. And so we're going to take that approach. So how are we going to do that? We're going to tell GPT what we want to do. So I'm just going to say, hello, I am building. I would like your assistance in building an application in Golang. This application is a 2D chess game. What do you suggest for building applications in Golang? Here, we're gonna start with this. Now, this isn't asking it to necessarily build a chess game, but it's getting it's getting ChatGPT to start priming its thoughts about what approach would it take to building a chess game. So as you can see here, it says building a 2D chess game in Go is a great project and helps strengthen both your game development and Go programming skills. Here are some general suggestions. So game engine, eBitten, since you're already familiar with Go, and eBitten, which I didn't say I was familiar with that, which I'm not super familiar, I recommend continuing to use it. It is lightweight, simple, and fits perfectly for 2D games like chess. It supports rendering sprites, managing input events, mouse, keyboards, and display text. And then chess logic, game rules, and moves. So it kind of goes through and kind of gives all the description, what it might do, piece representation, rendering, input handling, game loop, etc., etc. Perfect. So this is what I'm going to do. It's kind of already done that research. So I'm going to say perfect. Let's get started. Build me. I'm just going to go straight for the jugular and ask you to build me a fully functional chess game and Go. I'm not going to spend a whole lot of time looking at the output that it has here, but it's pretty reasonable. You've got your update, you've got your game loop, your run game, how it's going to update, how it's going to, etc., etc. Maybe help if I actually Okay. I don't know what happened with ChatGPT. I think maybe it took my text um in. Okay. So make dir go chess game. I've already got a directory set up here. Um, close this tab out. I already have this directory set up called ChatGPT. I'm gonna organize my folders like this because we want to be able to see. I have code with AI as kind of a parent folder, and then I have some subfolders here like ChatGPT, etc. So right now we're focusing on ChatGPT. Um, okay, so I played around a little bit with this. It's actually making a mistake here with Go because Go really favors Go mod these days with the newer versions of Go, and so this isn't really a great step. I'm not going to worry about the init on the package. I'm just gonna paste this, and you're gonna see that there's already an error here. So maybe just to be fair, we'll go ahead and we'll run this, but we're gonna call it not this. So we'll run this first, and we'll call it. I don't really care. It doesn't really matter to me. We'll follow the steps in the prompt, and then we'll run this. And I don't think that's gonna make a difference, but we'll try. Maybe I'm wrong. I'm definitely wrong. Okay, so if we go through the process, we get to the place where we need to be, where that's not a problem. Okay, great. So board.go, define an 8x8 chessboard and create a piece structure to represent each chess piece. Um, okay, cool. It kind of broke this up into different steps. So let's not that. Let's go here. Sorry, work computer is VS Code, home computer is code. Got to deal with it, I guess. Let's trust this author. New file. We're going to boldly trust and go where no man has gone before. Board.go. New file. Main.go. Right. All right, let's go back here. So now we got our board.go. Seems pretty reasonable. Board size is 8. That's true for chess. Here's a type called piece with a type and color represented. That's true. And then we've got a setup of the black pieces, setup of the white pieces, and these are just pieces represented. And then it prints out a given piece on the board. So we'll see what that looks like. Then we have a main.go, which is our main game loop. It went ahead and chose to go forward to this ebit or ebit n. I don't know really how to pronounce that. So we'll run with that, and we're going to paste this here just as is. That's interesting. It's highlighted some potential issues here with the tile size, the color. There's no need to use func.sprintf. Okay. All right. Well, it's constructive feedback, but it's not particularly a problem. Okay. And then it just says to run it. So let's and it says that it should open up a window with a basic chessboard where you can see alternating squares and pieces represented by their initial P, R, N, B, Q, and K. So the interesting thing is that I said I wanted a full game, and it said, "Hey, here are the next steps," but it only got me to a certain point. But let's see what this produces. Let's do a quick code review and kind of see if there's anything that just jumps out at me. So we've got a new game, okay, that represents a new game. We've got an update, handles game logic, moves, etc. Well, it knows that that's not implemented, okay. It's got our draw with the color light and dark, the boards, and then the print, debug print at, okay, it's good. As we know, it doesn't need to wrap that, but that's not a fatal error, so we're going to leave it alone. The layout, and then the main, okay. Everything seems pretty reasonable. Let me switch to just using this terminal here, and we're going to go and we're going to actually run what it says to run. Now let's see what happens. Undefined board size. Undefined board size. Um, okay. So I think it is defined, which is here, but that's inside board.go. So this is a, if we do actually go run and we do this, this should fix it. Okay. We'll, okay. Okay. So a couple of things. We got something, but it's not very impressive out of the gate. So we gave it no visual information. We just said, hey, this is what we want, and it provided back a window with boxes either labeled as dark and light with the representation of what the piece is in those given locations. Um, so let's be a little pushy, but let's not be. We'll close this just for simplicity. Let's be a little pushy here, and let's just say, um, good start, but that is not everything I want. I would like a full to be chess game with. Uh, I have provided. Let's go ahead and tell what we've provided, and assets directory with pieces labeled as such. And then we did give it lights dark underscore. I have a new keyboard and I keep misclicking. All right, so it's going about it, but it missed. I mistyped it, and so now it's slightly off. But that's okay. Um, uh, I'll just say my apologies. I'll stop it and I'll say my apologies. The files are in SVG format. SVG format with the following naming scheme: lights, dark, and we'll say underscore. This is the important parts type dot svg. Please provide updated code with this information. Be great if I could actually type correctly. Thanks for clarifying. Since your chess piece set assets in SVG format, we'll need to render them at raster images in Go. Fortunately, EBIN supports loading images from SVGs using external libraries like SVG Go to convert SVG images or using pre-builts like NSVG. So great. So it's running along the way. It's pulling in some additional packages. So we're going to copy those. We're going to go back over to VS Code and we're going to run that. No. Why does it want me to log in for that? Because it doesn't exist. Okay. let's try this out. So we'll copy this. This is the main.go. Oh no. Oh no. Well, it's still representing board as board. Okay. Let's roll it. Let's see what happens. I feel like it's mincing. Undefined NSVG. Right. So we're going to copy both of these and we're going to provide them back. We're going to provide them back to looks like there was a misunderstanding in my earlier response regarding the usage of NSVG. NSVG we need directly use go compare. Tile size does not have a built-in tile size constant. Instead, we manually define the tile size as a constant, which represents the size of the chessboard. Let's go ahead and fix that. Okay. A little slow here on the output, but I think that's because we're using the newer ChatGPT 4.0 model, which for some reason the newer models they come out with the token. So the way that really LLMs work is that they are giving you a prediction on the output of the text based on the previous input. So when you ask it a question, its response is actually that entire thing plus only one new token, which is a subset of a word or a word if the word is small enough. And then it refeeds that back into itself. And then a token is then produced. A new token is then produced based on the original question, the one new token plus the new token that was produced. And so LLMs are graded somewhat on how fast and slow they can do that. And so the newer models tend to, it almost feels as if they're handicapping them by default, and then they eventually speed them up. So okay, so let's see here if we just kind of switch this out and run. Okay, I'm just going to run go mod tidy because go mod tidy should just go ahead and take care of that for us. And then if we run failed to open SVG file, open assets light underscore pawn SVG, assets light underscore pawn dot SVG. That is no such file or directory, exit. It definitely assets. Oh, wait a second. Did I embed these one folder too deep? That's what I did. Okay, let me just move those up into there and we'll delete this folder. Move trash. Okay, there we go. Now let's try it again. That was my fault. That was not the LM's fault. Great. We have a chess board, but the pieces are not on the board. Great. We are making progress. We have a chessboard with colored tiles, but we do not have the pieces in the correct position on the board. Getting close. Not really. We're pretty far away. Okay. So I think it's abandoned board.go, which is a little scary here. Not super scary, but it's the board now in this structure is an 8x8 of the pieces. It does not reference board.go at all, and that maybe I'm wrong because it's calling a nip board here. But where's the nip board called? Yeah, nip board's inside of the main.go function now, which okay, I'm not like super upset about. Like maybe the decision for board.go was a bit overkill, but still I feel like things are starting to get splintered a little bit and the logic is being separated. Um, for those who are just joining here, we're making some progress. Um, we run this. We've got a chessboard right now, which probably could have whipped up myself in less time with less frustration, but we're making progress. So let's see here. Let's see where GPT is at. Okay. So here's your new file. I'm not going to read through everything ChatGPT is writing out. Honestly, I'm more concerned about not its logic process. Maybe we can go back and look, but really more about how it's getting, what it's actually producing, because I think that is more fundamental for what we're doing here. Okay, so I just straight updated it. Okay, so piece redeclared in this block. So board size here in board.go is a duplicate of, and pieces is of. So what I think we actually need to do is delete board.go. And then I think our problems go away. Right, okay. So right. Um, again, like I said, GPT just decided randomly to abandon board.go and keep everything in main.go. That's looking much better. That is looking much, much better. The only thing that's kind of inverse here is that typically your light pieces would be considered white and your dark pieces would be considered dark. Um, so we're writing shush underscore one. We're asking ChatGPT to write a chess game written in Golang, and so we're asking for it to produce a specifically formatted chess application using Golang. So we can kind of dive into the code if you want. But the idea here is that it's a little bit more obscure than just a web-based app for chess. So I feel like it has a lot less, it's also a desktop application. So it has a lot less source material. So it can kind of get there, but it's not just magically copy paste off the internet. It's actually running through and ensuring that maybe it's doing like some logic here and some specifics. Just kind of going back to the beginning, I'm a big fan of Golang. I think it is one of the best languages for backend data processing. It's strongly typed, so you have to deal with those issues and hurdles, but it's also strongly typed. So it really is a blessing instead of a curse, in my opinion, because I know the things that I write are going to work the first time. And I'll leave my opinions on Python on the table. Okay, so making some progress. Little update here. This is what we've got. So we can't move these pieces. We've got the black and white pieces transposed. So I think we can just tell it that we want the light and dark pieces in their proper location. I think it will understand that. So let's try it out. Great. I can now see pieces on the board, and they appear to be correctly organized, but we have the dark pieces in the white squares or in the white positions, and we have the light squares in the starting black positions. Can Can we flip this? So we're just going to ask ChatGPT to do it. I could do it, but I'm not going to do it because the purpose of this is getting ChatGPT to take us as far as we possibly can with asking it and letting it know in a human type language what it has done wrong, right? If we're going to want ChatGPT to assist us as a principal software engineer or as a software engineer, we're going to want it to do the work, and really we're just going to guide it with our observations. Um, I don't know why it chose light brown and dark brown for the square color, but I actually am a fan of this. I've kind of went through a few exercises of this, and I think I'm glad that it went that route. Um, I think we're gonna run out of tokens soon. I'm using the free tier of ChatGPT. That's also another good point here is everything that I'm doing right now is completely free. Now, when you run out of the free tier of ChatGPT 4.0 tokens, it downgrades you down to ChatGPT 4, and you can still interact with the chat, and you can still get code feedback, and you can still make progress. So we're not going to be completely unable to move forward here. But eventually, it's going to tell me that I'm no longer getting free goodness from the latest model. So it'll be a slightly less later model, but in some ways, they're more refined. And one thing that you'll get is much faster response times. Okay, so let's go with this. And let's update our code. Let's run it again. We're just going to blindly run. Hope it's not going to delete my hard drive. Aha. Okay, so this looks pretty interesting. No, so shush, I would not recommend using AI to learn code, but I do recommend that you utilize AI, or you're aware that AI is going to be an integral part of your workflow moving forward. Um, because if you learn to code with just using AI out of the gate, you're going to miss some of the core fundamentals of development, and you're going to miss some of the core fundamentals of how to become a better developer, understanding how to debug, understanding how to work through problems. However, just like with writing documents in Microsoft Word, you use autocorrect, spell correct, etc. You're going to want LLMs are going to help you in the future, and honestly, we may be more curators of what the AI does in the future as opposed to writing code ourselves. But someone's going to have to know at the end of the day, there's an interface to humans. So we're going to have to know how the bot works, right? How the robot works. Okay, so we're making progress here. So let's take a look at this and just say, okay, we don't have click functionality, but visually everything looks good. So let's kind of give some more feedback here and just say, visually, really things look great. Um, please add please ensure each move is validated, and only all right. So what I'm hoping is, and I've had some experiences with ChatGPT where you'll get some very varying results. So my visuals might be great, then I ask it for a change and it breaks everything that it does. And it's kind of like two steps forward, one step back. Now, the LLMs are getting better, the ChatGPT is getting better, the interfaces are getting better. So what I'm hoping is that's not going to be the case here. I've kind of primed it a little bit, like saying like, hey, like basically, don't mess with the visuals. Visually things look great. Please add these functionalities. So I'm hoping it won't break that. So we'll see what it comes up with. The downside is with GPT, because it's structured everything into a single main.go file, it's re-providing that same output every time, which is not super efficient. It's not super cost effective for me. I might suggest that it break it apart, but then it may lose context of the full visual picture. So alternatively, I don't really want to do this in ChatGPT. I would rather have this. I would really like to see this in a place where we're in Visual Studio Code itself, and inside Visual Studio Code that we are prompted for, or let me rephrase this. Sorry, I got slightly sidetracked. Inside Visual Studio Code itself, so that we can, in a specific file, ask for help, ask for assistance, and have an iterative process, not having to go back and forth to this chat. So, uh, well, that's sad. It didn't continue generating. There's a button. Okay, we'll see what happens. It just kind of cut off my conversation like midstream. Like that was kind of important. Um, okay, well, we'll see what the other model gives us. And I mean, I don't have an issue necessarily paying for a model. That's not really a concern of mine. But I mean, if I could do it for free, why? I mean, what free tools do we have out there, right? What free tools do we have available to give us what we want here? So let's just see what this generates and see how close we get. I did say I would have about a 4 hour time limit. I'm probably going to break this up into several like segments. Um, Probably do about an hour today, maybe an hour in the future. Well, it was about the same because we're out of. Okay, continue generating. Okay, we got something. I have no I have no faith that this is gonna work, but we're gonna try it. Oh, though the pieces uh, just disappear. This is awesome. Okay, so that's not great. Um, Back to the Jippities. Uh, hmm. Apparently, I'm having some sort of issue with the stream. Well, there doesn't look like there's any issues on my side. Experience buffering. The stream status is poor. Hmm. Okay. Well, it looks like everything's fine here as far as maybe my frame rate's a little low. CPU utilization's fine. Drop frames are fine. That's the first time I've ever done a live stream, so just kind of checking out what's going on here. Let's just kind of move forward and see if this kind of rectifies. I think we missed it in this one. Well, we can click the page or we can click the pieces, but we cannot move them. But they just disappear. What I Okay. What I want is for them to be draggable to the new square and for the move to be validated. If it is an invalid move, the piece remains where it was. If it is valid, it moves to that new square. Of course, I didn't spell disappear right. So I think I might just go ahead and pay for the open AI. Or the GPT 4.0. This is interesting that the is valid move only checks to see if it can move to a square that's not occupied by its own piece. Just a little bit more complicated than that. I guess it's done with the code. I don't really need to know what else it's got for me here as far as the key updates. All right, let's take a look. Okay, well, at least the piece doesn't disappear. Oh, I was able to move that one. Oh, wait a second. That's kind of cool. Okay, so it's not a click and drag. It's a single click. Then when you lift your mouse up, you get this red reticule of the possible places you could go. And then you click again. This looks like some sort of visual bug here. You click again for that piece to get set there. The problem is this isn't following chess rules at all. Okay, well sometimes the single click doesn't work either. Sometimes I can drag it, sometimes I can't. Okay, well we can't move on our own piece, but we can take the king. So we won, right? YouTube is not rooting. Okay. What's going on here? It says my connection's fine. Is the stream okay? YouTube is telling me that it's poor connection. So I'm just wondering if that is true. Okay, well then I'm just going to keep going and not paying attention to YouTube then. All right, so we made some progress here. Thanks, Shush, appreciate it. Made some progress here, but as you can tell, this is not following rules. So we have really two options here. We could just assume that it's the LLM that is kind of changed here, and maybe that's changed behavior. But let's just see what we get with the mini, and then we can come back and iterate on this later with the more advanced model. So we'll just say great. We'll just keep encouraging it. You don't know if these things have actual feelings or not. Great. Looks like we are making progress. And we can move pieces around, but we are able to make moves that are not compliant with chess rules. Can you provide, I'm going to ask for a very targeted thing because this is a lot in here, and updated, was it is valid move? Is that the name of the function? We're going to help the LLM out a little bit here. We're going to ask for some specifics, just because I want to try to give it the best possible leg forward that ensures we are only making valid chess moves. And then we're going to give it a little bit more here. So like when we start seeing things that aren't going exactly the way we want, we'll give it some like an EG, like queens can only move left, right, and on the diagonal. Pawns can only move forward unless attacking. And then we're going to tell it, just say, please, all chess rules are implemented. I realize this is a pretty big ask, but let's just see what we get here. Look, see, even it thinks so. Implementing a complete chess move validation system is quite involved due to the complexity of chess rules. Here's a general approach to implement validation for all pieces with simplified rules for the demonstration. We'll validate moves for pawn, rook, knight, bishop, queen, kings. And then here's the updated is valid move. So what I did here was I asked for a very specific function to be updated so that we can lower and reduce our scope. So if we take just this and we go back into our code, if we find that is valid move function that was pretty minimal previously, and we actually put this entire thing in here, they also included an ABS is patch clear, etc. function. We should, if things went well, which I would be highly surprised at this point if they do, that should give us some validation here with our moves. And so let's see if we could just out of the gate. Okay, that doesn't work. That doesn't work. This is good, right? So I should be able to click forward. Oh, that should work. That also should work. That should work. That should work. That should work. So let's see what was actually done here. Let's dive into the code that was produced. I realize this is a complex problem, and maybe I've really dug in too much into the Gippities here, and requiring too much of it. But I'm gonna give it a little bit of a leg up here. So what I'm gonna say is this. We're still having issues with the validating for moves. I suggest using something, a library in Go that already has chess move validation figured out. I'm going to talk to it like a human. Have you heard of the chess library by Not Know? Yes, the chess library by Not Nil team is a great choice for handling chess rules and move validation. It's a robust library that can simply simplify implementing chess logic in Go. And here we go. Oh, it updated the entire main.go for me. Okay, we'll wait. So what I'm doing here is I'm trying to give it a suggestion. Like if I was working with a junior developer or a junior engineer, and they were working on a problem, they were trying to figure out something on their own, and it was a problem that was already solved, I would say, hey, have you tried looking at this library? You know, like I said earlier in the call, it's kind of like we're working with a 2, 3, 4-year-old. So we're trying to provide suggestions to them, and they're going to make mistakes along the way, but they have access to all the knowledge of the world in a sense. They don't really have access to knowledge, but I think you kind of understand where I'm going here. So, we're just going to fix this real quick, and we're going to do a go mod tidy. I could ask GPT, or I can go back and look and see what it suggested, but it's not really, it's not going to do us anything here. All right. Oof. Looks like that did not work. Here are the errors that I am that. We'll just give them back. Am I hitting like a key that is causing it to want to record me as opposed to... Okay. Looks like there are some mismatches between the uses of chess library and its actual API. Let's address these issues step by step. And so it's giving me a new main.go. So I'm finding this pretty interesting. It's a process. As you can see, it's very iterative. Um, okay. Right. Oh, it's telling me to ensure some things. It's unsure that I know what I'm doing or I've done things properly. Right. All right, let's try this again. Still a problem. Less issues. So we're going to give this one more go, and we're going to see if it can resolve it. And if it doesn't resolve it with this next one, I'll look and see if I can resolve it. And we'll just kind of dive into the individual code and see if they're fairly easily resolvable issues. I suspect because the model switched to the mini, which is the more free version, we're not getting as a thorough review of the data. We're getting a faster output, which is good, but we may be getting less accurate. So I think on our next iteration, we'll kind of give it a fair shot and say, okay, this is where we're at, and kind of see what gets produced here. Oops, wrong button. I just recopied that. Oh no, this is the same. Yeah, so it's definitely new code because we didn't get the convert g.select square. So it fixed one of the issues, but not the other. So let's just see if I can from to chess.move. Let's see here, chess.move. Okay. So I know what's going on here. And that so I've had a little bit of experience with the not nil library. And the problem is that there is no from move a way to move with the board. You can provide a move, but when you create the structure, you actually have to provide S1 and S2 as the square from and the square to. There's no from and to, but the problem is that because they're in the chess library or the chess package, because they have that lowercase s, that makes them private, so they're not accessible. So there's really not a way with the API right now with not nil to actually construct a chess.move that I know of. And set those in such a way that you can then use that as a move. So what you have to do is you have to move with a string context. And so that is why it's failing. And that's a little bit harder to cognitively understand. And I think maybe that's why the mini library isn't working properly. So let's see what we can do here. Let's see if we can switch the model. At 142. Let me pull this off the stream for a second. Could also just like upgrade to plus, right? Yeah, I'll have to do that another time. I don't want to do that while I'm on a stream. It doesn't. It's not very comfortable for me. Typing your credit card information onto an online form while people are watching you on stream. Yeah, not happening. Um, Not saying I can't do it on another screen, but I am not being a victim of that mistake. So, okay. Well, YouTube thinks my connection is good again, so that's a good thing. So where do we want to go from here? Well, I think for today, um, I think I've accomplished quite a bit. Um, what I've demonstrated here today was the ability to use ChatGPT. In this case, specifically ChatGPT, prompting it for specific things and getting back specific code that can be executed locally on your machine. I obviously didn't go through a full sanitization process. I sort of just trusted GPT. That's fine. We could have been a little bit more thorough. Um, but the point here was how fast can I get something to a production state with ChatGPT that was somewhat of a complex question. So if we look here at what we've created, uh, with me not really providing much programming knowledge, I think, although there were some specifics where I said, well, this is this, this is this. Um, well, we don't have working code right now, so I can't really say. Let me go back a few iterations here. Let's take a look at what was actually good. I think what I'll do um, for what I should have done is constantly checked in the code as we went, so I knew each time we had a working state, and I didn't do that, and that's a bit of a problem. Yeah, that stinks. Let's see if we can go back to a good state here from our chat log. Yeah, I think this is the state here before I broke before things started really breaking down. Oh, that's when it replaced validate move. Just validate move is valid move. So this would be the state here. Got it. Okay. Yeah. Okay. And then let's put back that is valid move because I do like that. Um yeah, so this is when it gave us is valid move. So if we find where this definition is, we can replace this with this. And this is what I think are probably our best representation of what ChatGPT was with the 4.0 before we switched to 4.0 mini, that actually had it had the movement, but it was too strict on the rules, right? So we need a better rule library. So it's like, hey, can we use the not nil library to kind of validate our movements, and how do we transpose those? And so what I think what I'll do is on our next live stream, we'll come back to this and we'll focus on it, and we'll say, okay, what can we actually produce? How can we get ChatGPT to actually produce something that's useful and valuable? Because at this point, I just have something that's visually appealing. But as a senior or principal engineer, I if I receive this from a junior, well, there's still a lot of work left to do. So, but that was produced in an hour. So, I provided the icons. So, is this something I could have done in an hour by myself and had a more ready to modify product? Let's do this, right? So let's get into this. Um, and let's we'll call it 1 hour of chat GPT dash 4.0 dev. And then I'll create a branch checkout dash B, and we'll just call it my attempts human add not nil lib validation. Right. So just curious if I could. So I switched to another branch so that I can make some changes that don't affect where we're at with the AI. When we come back next time, I'll paste it in. But I want to see if I can just let's just pretend that this ChatGPT, this LLM, is a junior programmer, and it brought me this piece of wonderful cake. It comes up, it renders, but I can sort of move some pieces, maybe somewhat. It's got some like bug here with the clicking. It's making a suggestion, but really no moves are valid moves as far as I can tell. So why is that? So let's take a look at the valid move function. Right, is valid move. So let's see what's wrong with it. So is valid move from a game perspective looks and says if the 2x is less than 0 or the 2x is greater than or equal to board size, it returns false. The move is out of bounds. If the destination square is occupied by a piece of the same color, it returns false. So you can never move a piece on its own color. Okay. And if the piece type is a pawn, it checks to see if it's a valid move. Oh, it calls is valid pawn move. Gotcha. Okay. So it's not using not nil, so it's got this whole like process, and I don't really care about that actually. So what I really want to do is if we were to use the not nil library, there is a process that we can do. So if I cat oh, I see why. The wrong directory. So the not nil library has the ability, the not nil chess library has the ability of moving pieces, but the only way that you can move a piece is, and the only way that you can validate moving a piece is by creating a position notation and saying, okay, I've got this position and this is the string I want to do. So it's called move string. That's what I was looking for. So I think what I'm proving here is that it's going to take a few steps for me to even quantify this, right? Because you've got to have a not nil game set up, and you've got to then on that board make a move. So let's do this first. In the new game, we have a game and we have a board, we have pieces, and what would we call this? Here we go. So we want to implement this library. So what are the steps? So we have a game, which is in chess.newGame. which comes from this library. And on our game, we want to, where's our game here? I guess we could technically replace board, and that's a whole level refactoring that I don't want to do at the moment. So we'll create a chess game, and then what we'll do here call new game, which is just simply that, right? And we won't put anything in there other than that. So now when we come back down here to is valid move, we can g dot chess game dot valid moves. That gives us a list of valid moves, and that's going to be in a chess dot move fashion. And we can actually do valid. This is going to be the cheap way to do it. What we're going to do here is we're going to take and we're going to say for each move in this list of g.moves, moves, and we're going to say if move dot s1 let's see what a move looks like. A move has the S1 square, which is the size and the offset, and the S2 square, which is in an 8. So that puts us on the exact position. So move S1, I think, is the from, and then we can say that should be the 2y. Pretty sure this should be plus 2y. Then we can say and move dot s2, pretty much the same thing. Okay, well, if I can push the right keys on my keyboard, I might actually be getting somewhere here. This is actually the from, and this is the from. So if this is true, then we're going to say valid equals true. And we're going to break because we don't need to validate that anymore. And then we can take out all this and we can just simply return valid. And we can get rid of all these is valid functions in this ABS function. Right. So what we're doing is we're saying, hey, give me the list of valid moves. Let's loop through them and we'll see if it's actually valid. Now, is there a more efficient way to do this? Yes. Do I care about that right now? No. We're not really talking about efficiency. We're talking more about functionality. And so let's see what we got here. Okay. I still fail. So why is that? Oh, that was interesting. Okay. So we have no visibility into as to why. So only if it's true do we set it and then we break it, right? Um, it could be failing earlier. So we'll have to dig into this a little bit more. But for today, I think this is good enough. I'm gonna sign off here and kind of show you guys that GPT is helping in some regards, and it's going to be an integrated part of our future as a software engineer. It's going to be the cornerstone of what we do moving forward, and we're going to have to adapt to it. As you can see, it accelerated some of the development here, but still kind of ended with a product that was half baked, not fully finished, and would take me a little bit longer to fully flesh out here. So what we'll do in our next live stream is just take a look at it and say, okay, this is our starting point. This is where we left off. This is where the robot left us off. And let's see where it can take us from there. So we'll reconvene and we'll see where that goes. But I thank you for joining. And if you have any questions, comments, or things you want to see, please feel to let us know and we'll go from there. All right. I'll talk to y'all later. Signing out. Bye.